Hello everyone, welcome back. In this next segment of the lesson, we're going to be looking at some more measurement problems. I'm also going to be revising scale factors with you. Let's go to the board. Cool. So guys, as you can see, we're going to continue with what we started with. We're going to carry on with examples of combined shapes, but first things first, I'm going to remind you what scale factors are. So it is possible that the dimensions of a prism are changed by a certain factor. The number that each dimension is multiplied by is known as the scale factor. And we often refer to this as the scale factor of K. So it's essentially just saying that we can alter the surface area and the volume of a prism by multiplying certain sides by a scale factor. Let's go to the next slide. So, in general, if the dimensions of a regular polyhedron are changed by a factor of K, then the surface area changes by K squared and the volume is changed by K cubed. So it's just important to keep these two at the back of your minds. When I have changed lengths by a scale factor of K, that the surface area changes by K squared and the volume changes by K cubed. Please also just remember there are some exceptions to this trend. Cool. Let's have a look at our next example. So I have given you a particular cylinder. So the volume of the cylinder is 100 centimeters cubed. Also just a reminder, when I'm working with volume, my unit is cubed. So A has asked me to first determine the volume of the cylinder if the height is increased by a scale factor of 3. Then B has asked me to determine the volume of the cylinder if the area of the base, so it's the shaded region over here, which is my base, is doubled. Cool. Let's go on to A. So we know that the volume of this particular cylinder is 100 centimeters cubed. So we first have to determine the volume of the cylinder if the height is increased by a scale factor of 3. So I'm just going to stop at this point. This scale factor question is slightly different because I'm only changing the height by a scale factor of 3. I'm not also changing the radius by a scale factor of 3. So only my height would it be multiplied by a scale factor of 3. So instead of h in the formula, it's going to be 3 times h. Let's go back to the board. So we know that the volume will be equal to pi times my radius squared times 3 times h, because my height has been multiplied by a scale factor of 3. But I don't actually know what my height is, and I also don't know what my radius is. But what I do know is the fact that the volume is 100 centimeters cubed. So what I'm going to do is I'm going to rearrange how I've written the volume. Because it's all multiplication, I know that the order isn't important, because I know that I can swap it around because everything's being multiplied together. So I'm going to take the 3 out at the front, and in the bracket, I'm going to keep my pi r squared h. The reason why I've done that is because I actually know what pi r squared h is, because I know it is my original volume. So this means I'm going to have 3 times my original volume, which is 100, which means that the new volume of the cylinder, when the height has been increased by a scale factor of 3, will be 300 centimeters cubed. So we can see as my height changed by a scale factor of 3, this influenced my calculation because my new volume will be 300 centimeters cubed. Great, let's go on to B. So we now need to determine the volume of the cylinder if the area of the base, which is the shaded region of my diagram, so we can see over here that this is the base that we are referring to, is doubled. So guys, again, we're not changing multiple dimensions. We are just doubling the area of the base. And we know that the base of a cylinder is a circle. And if we are talking about doubling that area, the area of a circle is pi r squared. So if I'm doubling that, what do I have to multiply by? I'm hoping that we've got some 2's going on in your heads. So I'm going to have to multiply the area of the base, which is pi r squared, because that's the area of a circle. So it's going to be pi r squared times 2. And we're going to see how that affects my calculation. Let's go back to the board. So we know that the base is the area of a circle. And the base itself is what has been multiplied by 2. So we're going to have 2 times pi r squared, and this is going to be multiplied by the height. But again, what I'm going to do, which is similar to A, is I am going to rearrange it and take a 2 out at the front and leave pi r squared h in my brackets. I'm allowed to rearrange because it's multiplication, so the order doesn't matter. But again, I'm going to link back to what was given to me. I know that the original volume is 100 centimeters cubed, so I can replace the pi r squared h with 100. So it's going to be 200 centimeters cubed for my new volume. Cool, guys. I hope you're all still with me. We're going to go on to the next example now. So the next question has given us a chocolate factory, and I hope that this example doesn't make you all too hungry, because chocolate would be great right now. So a chocolate factory is constructed as follows. The room space is constructed as a right rectangular prism with a square base. So essentially we know that there's a square base. Let's change my color so you can see. So we know that we've got a square base, which is where each side is 30 meters. So we know that all of these lengths for the square base will be 30 meters. The height of the wall in the room is 10 meters. And the roof is constructed in the form of a right triangular pyramid with a height of 5 meters. So we know that the height of this particular roof is 5 meters. And the base of the roof is open. So essentially it just means that the space between the building and the rest of the room is open. So this layer will be open. So it's just some things to consider before we do our calculations. Cool, let's go to the next slide. So these are the questions that we're going to get through. We're first going to calculate the slant height of the triangular pyramid. Then we're going to calculate the surface area of one of the triangle faces of the roof. C is asking me for the total exterior surface area of the factory. And then D is asking me for the volume of the factory. So we're going to look at each of these individually, and we're going to discuss strategies as we go. So let's look at A. We need to calculate the slant height of the roof. And the slant height refers to this particular height. So the height of the slanted triangle, I need this height. So this is my slant height. So the square bases each have a length of 30 meters. The wall height of the building is 10 meters, and the height of the triangular pyramid is 5 meters. But if I'm going to be calculating my slant height, that means I'm going to need to form a right angle triangle so that I can do Pythagoras, because that will allow me to calculate my slant height. So if I redraw that triangle, we know that the height of the building is 5 meters. I want my slant height, but just to note what the base will be, because I know that the lengths of each of the walls is 30 meters, and because this right angle has come from the middle of the roof down, that means that the base would have to be 15 meters. So we are going to use our good old friend Pythagoras in order to calculate the slant height. So the slant height will be equal to 5 squared plus 15 squared because of Pythag. So we're going to use our calculator to work this out. So we've got 5 squared plus 15 squared, sorry, I've left a bracket out over there, which gives me 250. So we know that this is the slant height squared. So the slant height squared is equal to 250, which means I'm going to have to square root that to actually find out what my slant height is. So we're going to take the square root of 250, which gives me an answer of 15,81. So my slant height is equal to 15,81 centimeters. Sorry guys, not centimeters, meters. Great, let's move on to B. Cool guys, so B is asking me to calculate the surface area of one of the triangular faces of the roof. So we know that the roof is made up of 4 triangular faces, and I just want the area of one of them. And I know that the area of a triangle is equal to half of my base times my height. So we're going to say half of the base, which is, we know that the base of this particular triangle is 30 meters. That's directed by the walls, and that's going to be multiplied by my height. And my slant height I've just worked out to be 15,81. Great, so let's pop this all in our calculator. So we're going to have a half. Sorry guys, this fraction button is not my friend today. A half times 30 times 15,81, which is going to give me 237,15. Great, so that is the area of one of my triangular faces. So let's move on to C, everyone, to see what is being asked. So we now need to calculate the total exterior surface area of the factory. So how I'm going to do that is I first need to calculate the surface area of the pyramid, and then I'm going to add that to the rest of the surface area of the factory. But if I'm looking at the surface area of a pyramid, traditionally we would say the base added together with all of the 4 triangles that make it up. However, I've been told that the roof is open, so I'm not actually going to need the base in this calculation. So the surface area of the factory is going to be 4 times the areas of the triangles. So we worked out what the area of one of the triangles is, and we can steal that from the previous slide. So it's 237,15. Because we know we've got 4 triangles that make up the surface area, and then this is going to be added to 4 of the rectangles that make up the exterior of the factory, because I know that the factory is made up with 4 exterior rectangles, because I'm not including the top because it's open, but also the surface area is not including the floor. So we're going to add 4 times 30 times 10, because those are the dimensions of the walls. Then if I put this all in my calculator, it's going to give me the surface area of the entire factory. So we're going to have 4 times the area of the triangles plus 4 times the area of the rectangles. And sorry guys, I'm not going to have time today to get to the next question. So the surface area of this particular factory is 2,148,6 meters. Meters squared.